So we're going to continue on our modeling chemical reactions activity found on page 103 in your textbook, and we're on 5E. We're given the word equation potassium and water react to give us potassium hydroxide and hydrogen gas. And so our first step is to write out our skeleton equation. So I've got potassium, the metal, plus my water, going to make potassium hydroxide. My potassium makes a positive 1 cation, and my hydroxide ion is OH negative. And so my neutral compound from crisscross is KOH, 1 potassium ion, 1 hydroxide ion. And I'm making the state aqueous because I've got water there. It's taking place in water. And then we've got hydrogen gas, where hydrogen is one of those diatomic elements where he comes in pairs. Now we've got a couple of things going on here. We've got potassium and water reacted to make potassium hydroxide and hydrogen. Now let's do our diagrams, and I'm going to have potassium be green, so I'm going to draw a green circle there to represent my potassium. I've got my water, I've got my hydrogen in blue, and I've got 2 hydrogens, and I've got a oxygen there in the middle. Now when I go to do my product, I've got potassium hydroxide, and I want to treat the hydroxide. I can treat them one of 2 ways. I can treat them as a unit when we're dealing with polyatomic ions. That's the easiest way. Or I can treat them as individuals. So let's do the individual first and see how that turns out. So I've got my potassium, 1 potassium, 1 oxygen, 1 hydrogen. And then I've got my hydrogen gas, where I've got 2 hydrogen circles are together. Now when I take a look at my diagrams, one of the things that I notice right away is I've got in my water, I've got the red and blue circle together, I've got the red blue circle together as well. And so that shows me this is where this hydroxide ion is coming from water. And so I want to rewrite my water so that instead of it's H2O, I want to show it where it's going HOH. And that way I can see where the hydrogen comes from and where that hydroxide ion is coming from. And to be consistent, I want to treat that hydroxide ion as a single unit. I'm not going to be separating that oxygen and hydrogen from each other, so I want to actually draw them as one single color. And I'm going to change that color over to purple. So I'm going to erase my red-blue circles that I've initially drawn here, and I'm just going to draw one big purple circle to represent the hydroxide ion. I'm going to take that purple and blue, that red and blue, and I'm going to change it into one big purple. And now, when it comes to my balancing, I don't have these blues showing up in multiple different areas. I can take a look at it individually and see, okay, where is that hydrogen coming from? Where is that hydroxide coming from? And I'm just making it a little bit more simpler, and I'm just going to have my HOH up to represent my water and my skeleton. HOH. So when I go to balance, looking at my water, or looking at my colors, if I look at potassium, I've got 1 potassium here, 1 potassium here. So my greens or my potassium is balanced. When I look at my hydrogen, I've got 1 hydrogen in reactant side, but on my product side, I've got 2. So that tells me I need to draw another one of my waters. So I need another blue hydrogen and another purple hydroxide. And now when I check, I've got 2 hydrogens on my reactant side, 2 hydrogens on my product side. Now I'm ready to balance my hydroxide ion. I've got 2 on my reactant side because I've got 2 water molecules going on here, and I've got 1 on my product side. So that means I need to draw another potassium hydroxide. So I take my potassium hydroxide, got a potassium, and then I got a purple hydroxide. And now I've got my hydroxides are balanced. But oh, wait, I can visually see right away I've got 2 potassiums. I've got 2 green dots on my periodic side, but only 1 on my reactant side. So I'm going to need to draw in another potassium. And so what I've got is I've drawn 2 potassiums, 2 waters, and I've also drawn 2 potassium hydroxides, but I only have 1 of the hydrogen gas. So when I go to write my balanced reaction, my coefficient is the number of drawings that I did for each reactant and product. So I drew 2 potassiums, so that means my coefficient for potassium is 2K. It's 2Ks is for my balanced reaction. I drew 2 waters, so my coefficient for water is going to be 2. And now I'm going to write water the way we normally write the water formula, which is H2O. It reacts to produce, I've got 2 of my potassium hydroxides drawn, so that means I got a coefficient of 2 in front of my potassium hydroxide. And I only drew 1 of my hydrogen gas, so I'm going to only have 1 of my hydrogen gas molecule. And so now I've got this guy balanced.